Okay. So, okay, let us start solving. The first question that I would ask you to solve is this one. This is a 2014 question, session 3. Okay, a signal flow graph has been given to you. Okay, and it has been told that this H1 is equal to B1, H0 equal to B0 minus B1 into A1, and you need to find the input output transfer function. So, as usual, I will be giving you 3 minutes time to solve. I would ask you after 3 minutes.
You are not sharing your screen.
Okay, I'm not sharing the screen. Okay, I'm sorry. I'm sorry. Okay. Okay. Is my screen being shared now?
Yes, yes.
Okay. Good. So let us start with the very basic sum. Okay. The basic thing that we have been doing for a long time now. Okay. So you see a signal flow graph has been given to you, and it has been told that. Who is that? Please mute yourself. Okay. It is. Please mute yourself during the class. It becomes difficult. You unmute yourself when you have to answer any question, or else don't unmute yourself. Okay, so a signal flow graph has been given to you, and it has been told that H1 is equal to B1, H0 equal to B0 minus B1 into A1, and you need to find the input output transfer function. So these are the options that you have, and I will give you 3 minutes time to solve. You try the question out and then tell me what answer you are getting. So we have done this signal flow graph quite a bit of time. It has been repeated quite a bit of time. We have been doing this for a long time now. If anybody gets the answer, please unmute yourself and you can say what answer you are getting.
C.
What you are getting?
C.
C. Okay. Anybody else with the answer? Okay. 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 3 minutes time is gone. So yeah, C is the answer. You are correct. Let us see how to solve this. Once again, we are using Mason's gain formula for that. And the first step is to jot down whatever forward path gain you have and whatever loop gains you have. So you see from the signal flow graph that has been given to us, there are two forward paths, right? The first forward path is along the is shown by the flow of the cursor over here. So you see, this is the first forward path, H1 into 1 by S into 1. So that is H1 by S. So what is the second forward path gain? That is the straight line, which is H0 into 1 by S into 1 by S. So it is a0 divided by s square. So we have two loops over here. That is loop 1. This is the bigger loop, that is 1 into 1 by s into 1 into 1 by s into minus of a0. So you get minus of a0 divided by s square. Loop 2 is a smaller loop, that is minus of a1 divided by s. So you have to observe that these two loops are touching loops. They are not non-touching loops. Okay. So whoever has unmute himself or herself, please mute. Okay.
Sorry, sir, please excuse me.
Okay. So after doing that, after you have jotted down whatever forward path gain and loop gains that you have, you go to the next step, which is, in which you find the delta term, which I have defined previously also. I have written the definition here also. That is 1 minus sum of individual loop gains plus sum of all possible gain products of two non-touching loops. Now you see the two loops that we have over here are not non-touching. So these terms becomes equal to 0. What I am left with is 1 minus L1 minus L2. Now if I replace L1 with the corresponding expression that we have got in the previous slide, what we have is 1 plus a0 divided by s square plus a1 divided by s. So now this delta 2 term is 1 minus sum of individual loops which is not touching the forward path, that is G2. Okay, so which one is G2? That is a straight line. That h0 into 1 into 1 by s into 1 into 1 by s into 1, the straight line. So we see that both the loops L1 and L2, this is L2 and this is L1, both the loops are touching this forward path G2. So this term becomes equal to 0 because there are no loops which are not touching the forward path G2. So in that case, delta 2 becomes equal to 1. Now if I look at the term delta 1, we find that if I consider the first loop gain, that is G1, which is H1 into 1 by S into 1, we find that loop L2 is not touching this forward path, this loop, that is 1 into 1 by S into minus of A1. This loop is not touching the forward path G1, G1. So in that case, what I have is delta 1 equal to 1 minus L2, because L2 is the loop which is not touching the forward path, that is G1. So I have replaced L2 with the corresponding expression, that is minus of A1 divided by S. So minus minus becomes positive. So I get 1 plus A1 divided by S. So the next step would be simply, you have already found out G1, delta 1, G2, delta 2 and delta. You simply substitute each of the terms with their corresponding, expressions, and you end up getting h1 by s into 1 plus a1 divided by s plus a0 divided by s square divided by 1 plus a0 by s square plus a1 by s. So now the next step would be replacing h1 and h0 as per the question. So if we do that, we end up getting h1 equal to b1 and h2 equal to b0 minus b1 into a1. We replace these two expressions in this bigger expression over here. So if we do that, we will get this expression. So the correct answer is C, which Anubhav and some other people has also got. Who was that other guy who got this C? That is Shahadat, right? Was it Shahadat?
Yes.
Okay, good, very good. Okay, it's a simple sum. Let us move to the next sum. Let's see what we have next. Okay, so the next sum is so there is a seesaw system whose transfer function is indicated as GS, and there is a feedback transfer function. Maybe there is a sensor which is a transfer function HS with which you are measuring the output, and then it is told that mod of GS into HS is always less than 1. So which of the following statement do you think would be true for the system? Is the system always stable, or is the system stable only if the zeros of the GS into HS lie in the left hand side of the S plane, or it is stable only if the poles of GS HS lie in the left hand side of S plane, or it is not possible for us to say from this information? Which of these four options would be correct? So I would be giving you 3 minutes time again to solve the question, and then I would ask you. And I would ask the reason for your answer.
Option C, sir.
Okay, somebody is saying option C. Who is that? Who said C? Let me see.
Veeraya.
Okay, okay. If anybody thinks that Vidya is not right, they can come in and say that he or she is wrong. Whatever you feel, you can say. So, anybody else with any other answer other than Vidya? It is already more than 3 minutes that I have given you to think. Anybody else with the answer? Anubhav,
Yes, sir.
what do you think would be the answer? Yes,
So three.
C you think would be the answer, right?
Yes, sir.
C you think would be the answer. Abhishek? Abhishek, are you there? What do you think would be the correct answer? Which option do you think is correct? You can just type in. You think it is D. What is D? Acha, information is not enough. Okay. Okay. Vidya has already told. Shahadat? Shahadat, what do you think is the answer?
I think D, sir. I was not able to get any reason for it.
Okay. You also think it is D. Okay. Venkatesh Ayappa. Venkatesh, you are there in the meeting. If you are there, you can just unmute yourself if possible. Naimisha, are you there in the meeting? If you are there, you can just say which option do you think would be the correct one. I've given you enough time to think. You should have thought about it, and I'm hoping that you are trying. Okay, she has no idea. You think Venkatesh says it is D. Okay, okay. Anubhav, I'm starting with Anubhav because on the very first, his name comes on the very first. Oh, now I've left out Navkirti. Navkirti, what do you think would be the answer?
So I don't know about the answer, but looking at the question, they have just given us the magnitude of open loop hole. So predicting the stability from that, I don't think so. It's possible.
You don't think it is possible. So you also think it is D. Good.
Yes, sir.
Okay. Anubhav,
Yes, sir.
yes. So, what do you think is the ultimate tool or the the final court of appeal? When you are trying to find out stability, when you are asked to comment about the stability of a system, what do you think would be the best tool or the final the final court of appeal? That beyond that you cannot go anywhere else. If that test gives you some result, if the test says that it is not stable, then it is not stable. So, what do you think is the best test to identify whether the system is stable or not? May it be minimum phase system or may it be non-minimum phase system? What is the best tool for it? What do you think?
Sir, sir, pole should be in the left half plane.
That is a condition. What test can what test
For
can you,
close loop,
no,
for
yeah, just a minute.
Nyquist plot,
Venkatesh Ayappa is saying minimum phase system. No, my question is which test or which, method you should use for both minimum and non-minimum phase system to identify whether the system is stable or not. What is the test that you would do so that,
bounded output. It should have bounded output.
bounded input, bounded output.
Routh-Hurwitz criteria?
RH
Very
criterion,
good.
sir.
Who was that? Yeah.
RH
Now,
criteria.
Routh criteria is there, but Routh criteria also has a problem, which I have told before in some other class. See, Routh criteria,
Sir,
if the
Bore plot.
Bode plot for non-minimum phase system, is it easy to do a Bode plot? What do you think?
So Nyquist plot for
Nyquist plot is the correct answer. Nyquist plot is the ultimate court of appeal. No. So, would you like to think one more time on the lines of Nyquist plot, or would I tell you the answer? The answer is not C. The answer is not D. Can you think along the lines of Nyquist plot and come up with the answer?
Yes, sir, could please show the question again?
Okay. So I've already told you that actually I've given you the answer itself, but I want you to come up with a reason for it, not just the answer, but a reason. Why are you thinking?
One way we can say, since even if it would be positive feedback system, then the output we get is G upon 1 minus GSHS. since GSHS is always less than 1, so our system is always, our system will be always stable. Because GSHS never become 1, so the denominator term never becomes 0. So our output never becomes
No,
infinity.
I'm asking you to think along the lines of Nyquist plot. How
Sir,
to say it?
option B. Option B.
Option B is not correct. So there we are left only with option A. Tell me the reason why you are thinking option B or option A, whatever you are thinking. Why are you saying it? How can stability? I mean, what you are talking about stability? It has only been told to about zeros on the left hand side of the S plane. So if it is a non-minimum phase system, it would be on the left hand side of the S plane. So it's a minimum phase system. Not it is not told about right. Sorry.
It is not enclosing -1, 0.
Absolutely, absolutely. So whatever be the case, it is never going to enclose that that -1, 0 point. It is never going to enclose that point. So how do you determine whether the system is stable or not? Okay. So that whether a system is stable or not, that will be given by the number of encirclements of this critical point, that is -1, 0, this point. How many times the polar plot or the Nyquist plot has encircled this point. So that a number of encirclement must be equal to z minus p, where z is the closed loop poles of the system and p is the open loop poles of the system, right? So you see there are zero encirclements. If there are zero encirclements and the open loop system is stable, so the closed loop system also has, so z has to be equal to 0. If z is equal to 0, then you see, if z is equal to 0, that means there are no closed loop poles on the left hand side of the S, on the right hand side of the S plane. That essentially means that your system is stable. So as you know, polar plot is not unique. It may have happened that the polar plot starts from here or it ends over here. It is not intersecting this line. There may be several possibilities of the polar plot. But there is one possible polar plot that I have drawn. Okay, it is one based on the information that is given to me. It is told to me that at any frequency, the magnitude of mod of GS into HS is less than 1. If it is less than 1, it is never intersecting this unity circle. If it is never intersecting the unity circle, then it is never encircling this point. If it is not encircling this point, that means your gain crossover frequency is not defined. That means your phase margin is going to be infinity. System is always stable.
Sir,
Okay? Yes.
sir,
Yes.
we check -1 encirclement of -1, 0 point
Yes.
or graph of 1 plus GSHS.
So in that, so if you are considering 1 plus GS into HS plane, then you have to consider the encirclement of the origin. Here, why are you plotting in GS into HS plane? Because GS is the open loop, you can consider it as a plant. GS is the plant or the controller that you have designed or whatever it is. So it is on the forward path. Okay. So, and you have the measuring instrument. You know with what you are measuring, the sensor. So these two are known to you. So it is far more convenient to compute GS into HS. So 1 plus GS into HS is just a shifting of the origin. So if you do 1 plus GS into HS, then this point gets shifted to this point, to the origin. Okay, so in that case, if you are plotting in 1 plus GS into HS plane, you have to check the encirclement of 0, 0, that is the origin. If you are considering, if you are plotting in GS into HS plane, then you have to consider the encirclements of -1, 0. So in polar plot, you plot GS into HS. So that is why it is very much called. Then again, you have to draw another plot, which is 1 plus how the plot will be shifted by adding 1, and then you have to check the encirclement of the origin. But as it is far more convenient for us to plot this in the GSHS plane, so we consider the GSHS plane. So if you are talking about 1 plus GSHS plane, you have to see the encirclements of the origin. If you are talking about GS into HS plane, then you have to see the encirclement of -1, 0. That is the critical point. Okay.
Are we concerned with the closed loop stability in this question?
Which is concerned?
We are concerned with closed loop stability.
we are always
This is
concerned with the closed loop stability. The open loop stability, a plant that you have at hand, the plant that you have at hand generally is stable, and you consider the open loop pole equal to 0 unless until it is mentioned that open loop system is unstable. You consider that the open loop plant that you have is stable.
so for closed loop stability, number of closed loop poles. Yeah. Okay. Okay. So I got it.
Okay. Okay. So
Sir,
let us, yes.
sir, please explain this with the formula n equal to
Huh.
p minus
Number of encirclements that is equal
sir,
to number of
one.
that is equal to
In
z
this
minus
question,
p. Okay, you write that in your paper. Number of encirclements n is equal to z minus p. Okay, so this p is the number of open loop poles on the right hand side of the S plane. Number of p is the number of open loop poles in the right hand side of the S plane. Z is the number of closed loop poles in the right hand side of the S plane. Okay, so now as I am saying that the plant that you have at hand, that is GS, that is stable, so P is equal to 0, and number of encirclements n, that is equal to 0. That means Z is equal to 0. If Z is equal to 0, that means number of closed loop poles on the right hand side of this plane is equal to 0. So the Z and P are number of closed loop poles on the right hand side of this plane, and P is number of open loop poles in the right hand side of this plane respectively. So this you have to keep in mind. Is it okay, Anubhav?
yes.
Okay. So can we move to the next question, or should I wait? Is it clear to everybody? Is it crystal clear to everybody?
Yes, sir. Yes, sir.
Okay. Good. Very good. Let us move to the next question then. Okay. So these are very similar sum that I have done the previous day. Okay, the pole zero plot has been given to you, and you have to choose which is the most appropriate answer for the plot for the transfer function that has been given to you. So I would again give you 3 minutes, and after that I would ask everyone why they think and what they think and the reason for what they are thinking.
D
You think it is A?
D dog.
Okay, D. Okay. Okay. Anybody else who thinks D is not correct can challenge or whatever you want. Okay, 3 minutes time is up. I would ask questions now. Okay, Anubhav has said it is D. Shahadat, what do you think is the answer?
I don't know.
Yes?
I could not get any answer.
You are in the you are there in the last class, right?
Yes.
Okay. Navkirti, you are also there in the last class. What do you think is the answer?
So I couldn't figure it out, but I think if I look more to it, I can.
Okay. Vidaya, Vidaya, are you
I'm
there?
sorry, sir. Yes, sir, I
Yes.
am there, sir. No
O-
idea, sir.
Okay. Abhishek Sharma.
Option D,
No.
Sadhu.
Okay. Yes. Yes. Option D, correct? Okay. Okay. So Naimisha, you can you say which do you think is the correct answer? Okay. Okay. Can you tell why do you think it is D?
We have to find the h of omega, and that is only the imaginary axis.
Yes. Why is it on the imaginary axis?
Because it's the S plane, and j omega axis is the all the set
And
of omegas.
and why would we put S equal to j omega? Why is the reason that of putting S equal to j omega?
Because they have asked for h of omega.
Is there any other reason why they have asked for h of omega? What for for determining the frequency response? What do you do? How do you manually find out the frequency response of a system?
Replace it by j omega.
Why do you replace it with j omega?
Because it's output only to sinusoidal.
Correct. It is a output of a sinusoidal function of a sinusoidal input of a particular frequency. What you manually do is you input a sinusoidal signal and you see what effect the system has on the sinusoidal signal. What you do to find out the entire frequency response, you keep on changing the frequency of the signal that you have applied. You use a function generator for it. Say suppose you are inputting some 10 sine omega t, so you keep on changing the frequency of the signal that you are applying to the system, and then you check at the output what output you are getting. So based on the amplification that it has on the sinusoidal input and what phase difference that the system is creating, you draw the Bode plot, that the magnitude plot and the phase plot. That is how mechanically it is done. Whatever you have learned is the mathematics portion, the mathematical modeling of the system. You replace with j omega, and then but you have to prove whatever you say, whatever you propose mathematically, you also have to prove experimentally. So this is how we actually go for it. So that's why we replace S with j omega, because we are concerned with the output to certain sinusoidal functions of certain frequencies. Okay, so I would go through the solution again because I have done a very similar sum the previous class. So you see that j omega, or when I replace S with j omega, that means we may be anywhere on this line. We can be anywhere on this j omega axis. Okay. So for illustration, I have chosen a point like this. It may be over here, it may be anywhere over here or here, anywhere. For illustration, I have chosen a point like this. So what is this S minus Z1? This S minus Z1, see, S is this point on j omega axis. Z1 is over here. So you have a vector like this. So S minus Z1 is this vector. S minus Z2. So S is this point and Z2 is this point. So S minus Z2 is this vector over here, the red vectors. So all the vectors that are subtended by the zeros, I have indicated with the red vectors, and the vectors which are subtended by the poles to the point S, which may be any point on the j omega axis, is indicated with a blue vector or a blue line. You can see on the screen. So what you see is this blue line has a length which is equal to this red line, and that is true for all the blue and the red lines. See, this line has a magnitude which is equal to this line. This line has a magnitude equal to this line. This line has a magnitude equal to this line. This line has a magnitude equal to this line. So if we find the magnitude of this expression, the magnitudes of the denominator and the magnitude of the numerator will cancel out each other. So you end up getting HS equal to 1. Okay, so the correct option should be D. So is the concept clear to everyone? What I have done a very similar sum the previous day. I've explained it one more time. Those who are in the previous class, I was expecting that you people would be able to find the answer. Anubhav has done it. That is good. Anubhav has understood what I was saying the other day. So the key point or the key thing that you have to remember keep in mind is if the poles and zeros are the images of each other across this geometry axis, then this phenomena would happen. Okay, because the reason being these vectors are being cancelled out. The magnitude of the vectors becomes equal and they would be cancelling out each other. So you will get a perfectly flat, unity magnitude response. So a very similar question was asked previous day. Okay. So everybody from here are from electrical background, or there are someone from EC background also?
Electrical, sir, myself.
Okay. Everybody else?
Electrical, sir.
I am from EC.
Shahadat is from EC. Okay. Naimisha, you are from EC or electrical? Navkirti, you are electrical, right?
Yes, sir.
Okay. Anubhav is also from electrical, right?
Yes, sir.
Okay. So you people are conversant with power electronics, right?
Yes, sir.
Okay. You have studied power electronics. You can answer question on power electronics.
Yes, sir.
Okay.
We will try to answer.
Okay. Abhishek, can you answer or you haven't yet studied power electronics?
नो सर, मैं अभी डिप्लोमा किया हूँ सर, तो बस अभी भी बीटेक में ज्वाइन करने वाला हूँ।
Okay.
तो ऐसे बेसिक पढ़ा हुआ हूँ।
Okay. 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 Then I will be giving you one question on power electronics and let us see what answer you get. Okay. Okay. Let us do the power electronics question. Shahadat, if you are from EC, then maybe this question is not much of use to you.
Okay.
Okay. So this is the question that is displayed on the screen. Okay. You need to find D. These are the options that we have. I would ask the reason of, I would ask your approach and your reason. Maybe I have mistakenly shown the answer while, zooming out, but I would ask you the reason why you are getting and how you are getting. So try
डेल्टा
this
आई
out.
एल जीरो कर देंगे.
हाँ.
डेल्टा आई एल को जीरो कर देंगे.
Delta IL 0.
No, let me try it.
Try it out. Try it out. Try it out.
Yes, yes, C is the correct option.
Okay, how are you doing it?
So for the conduction to be at the boundary of continuous and discontinuous, the, the ripple current should be such that it becomes zero. So we put IL minimum as
The
zero.
ripple current should become zero. How can the ripple
No,
current
no,
become
no,
zero?
not ripple current. The current curve should becomes zero. It means uh, for continuous conduction, we have continuous current supply. For discontinuous, the current becomes zero for certain period of time. So for continuous to discontinue, continuous for at the boundary of continuous and discontinuous, it becomes zero just at the end of cycle. The minimum current through inductor becomes zero.
Zero. Okay, okay,
Uh,
okay.
so,
Yes, yes, yes.
so the minimum current is the inductor current minus half of the ripple. IL
Correct.
is equal to del IL by 2. So from the equation BL is equal to L del IL by dt, we find del IL, then we took half of this, and the IL is equal to V naught by R. We put V naught as dBs, and
Correct, correct. You are correct. You are
after
correct. Yes, it is
performing all
correct.
the
It is okay.
calculations.
Okay. Let me just. Anybody else who has answer who has tried the question? Navkirti, have you tried?
Yes, sir, but I couldn't get that.
Okay. Vida.
No, no, sir.
Okay. Okay. So let me explain the solution. Okay. So see, during the turn on time means this switch is on. So you can consider this switch as a short. This diode would be off because the moment this switch is on, plus Vs appears across this diode and the diode becomes reverse bias. So the diode would be off. So you have a battery in series with the inductor and there is a capacitor across the load that you have. Okay. So what is the voltage applied across the inductor in T on time? That is Vs minus V0 because at this point the potential is Vs. At this point the potential is V0 because there is a voltage stiff element over here. C capacitor is a voltage stiff element. So you will say that the ripple is very small, almost negligible, and you say that the voltage across the output terminals is constant. So you say that the voltage across the inductor is Vs minus V0 during the turn on time. During turn off time, the moment you turn this switch off, the energy stored in the inductor would be the inductor can never be kept in an open circuit. Yes, yeah. I mean when a current is flowing through the inductor, you can never keep this in open circuit. That's why we provide this freewheeling diode. The moment you turn this off, there will be voltage spike. I mean, if this was some switch which was turned off, then there will be voltage spike across this. However, it is diode over here, so it would turn on forward bias this diode and the current starts conducting in this loop. So then the voltage across the inductor becomes minus of V0 because this is plus, this minus, this minus, this diode gets shorted. So minus terminal comes over here. So the voltage across the inductor becomes minus of V0. Now you have been told that the inductor current is in the boundary of continuous and discontinuous mode. What Anubhav was saying was the current waveform would look somewhat like this. That is, it will go from minimum value to maximum value and then go to the minimum value. For boundary condition, this minimum value would be 0. So if this is the delta L, that is the ripple in the inductor current, the average value of this inductor current would be this. That is I min plus I max divided by 2. That is delta L divided by 2 would be the average value. So this is delta L by 2. That would be the average value of the inductor current. If that is the case, what we have is delta L average is IL average would be delta L divided by 2. Now delta L, I have told you that during the off condition, when the switch was off, the voltage across the inductor would be minus of V0. So you have V0 divided by L. So this 2 comes from here into T off. During T off time this is happening. So T off means 1 minus D into T. So and then IL average you have is equal to V0 divided by R. So this the current that is flowing through the load. So what we say is that this current which is flowing through the inductor has a ripple in it. This ripple current flows through this capacitor, and the DC part of the current flows through this resistor over here. Okay, so this DC part or the average part of the inductor current is flowing through this resistor, and the ripple current is flowing through this capacitor. So the average current, the average voltage across this load is V0. So based on that, you can say that IL average is equal to V0 divided by R. So you equate these two equations, equate V0 divided by 2L into 1 minus D into T to V0 divided by R, and from there you get the expression for the duty cycle. Okay, so that would be the answer for this question. Okay, so today one more question I would do and then I'll put an end to it. 2014, is this the question? Yeah. So I would expect everyone to answer this question without using a pen and paper. Without using a pen and paper, I want you to answer this question. So tell me, which option do you think would be correct? There are two signals, S1 and S2, and which is applied to the deflection plates of the oscilloscope. And the signal S1 is this triangular wave that we have, S2 is this square wave, and these are the options given to you. What do you think would be the correct answer?
D. C.
C. Okay. ভাই ক্লাস চলছে আমি একটু পরে ফোন করছি Anubhav says it is C. Anybody else who would like to try? Shahadat, have you left or are you there in the meeting?
I am here.
Okay, what do you think would be the answer?
I haven't read about oscilloscopes, so I don't know.
No problem. There's no need for to read the oscilloscope. That is why I've asked you to see and use your logic. This is more of an aptitude question more than a technical question. You were the one asking about domain and range last day, right? I told that it was just one cycle. Shahadat?
Yes.
Yes. So I'm expecting that you would be answering this question. There is no reason you shouldn't answer this question. Anubhav says it is C. Anybody with the answer yet? Anybody except Anubhav? Navkirti? Okay. Abhishek? Vida?
Option B, sir.
Option B. Option B is what? Option B. Okay. So option B and option C. Anubhav said option C. Vida is saying option B. Okay. Shahadat. I'm counting on you. Yes.
I did not get it.
Okay. So let us see. What are the values S2 can assume?
-1 and 1.
-1 and 1. There are no other values, right? It S2 cannot assume any other value other than -1 and 1. So if you move along this line, so S2 is along x-axis. S2 has been put along x-axis. So if you move along this line, S2 is also assuming any value between 1 and 0, any value it can assume. So B cannot be the answer. Same is the case with C. So if you move along this line, S2 can assume any other value between -1 and 0, or any other value it can assume. So it would either be A or it would be D. Now can anybody say whether it would be A or D?
E.
D. Somebody is saying it is D. Who is
D,
that?
sir.
Sir, please explain again why you rule out C.
Okay. See, S2 has values only 1 and -1. It can only assume two values. So if you are plotting S2 along x-axis, you only have 2 points, this 1 or -1. You cannot have any other point in this line. So if you go to the option C, you see S. So if you move along this line, that means S2 has several other values between 0 and 1. That is not possible, right?
Sir, for the graph on the oscilloscope, we took the resultant of two curves.
5,000 में अगर दो किताबें
It is not the resultant of it is not, you are not doing x plus y.
Option A.
Option A. This is Shahadat. Is it Shahadat?
Yes.
Yes, I was hoping that you would get this right. Yeah, it is A. It is correct. A is the correct one. See, between the I mean, look at the period t/2 from 0 to t/2. So S2 is +1, and when S2 is +1, what happens to signal S1? It is moving from 0 to 1 and 1 to 0. So when S2 is +1, Y is moving from 0 to 1 and it is moving again from 1 to 0. What happens when S2 is -1? When it is -1, what happens to S1? S1 is moving from 0 to -1 and then again back to 0. So 0 to -1 and then again back to 0. Did you get what was the reason behind this question?
Yes.
See, so most of the things, you see, the good thing or the thing that I love about GATE is not always you need to there's no need for you to read CRO. You just have to use your logic. That is the beauty of this exam. That's why I love this exam. Anyways, okay. So today we have already we are already at the end of the session. It is already 8. So it's a 1 hour session. So we have done 4 or 5 sums today, right? Okay. Good. So the next day I would be doing again control systems, and I have basically what is done is every session I am allotted 3 questions. Okay, so 3 questions are too less. So that's why I do some additional questions so that I can get some more insight into, so that I can give you more insight into some topics.
Sir, the last question is related to Lissage US pattern.
Is it related to
Lissage US patterns.
Lisage's patterns? Of course it is, but there is no need for you to you always have to go through that. But
Technically I understand your explanation, but I want to get feel of the question. That's why I
so
asked.
Lisage's patterns come when there are when sinusoidal signals you are applying, and then getting you are applying sinusoidal signal to one axis and the another sinusoidal signal to the other axis. Based on the frequency and the amplitude, you will get intersections in the x and y axis. So yeah, so if it was sinusoidal signal, it would have been then the formula that we use and all those things, that would have been easier for you to apply. But in this case, it is not a sinusoidal signal. Anyways, so thing is, so we have come to an end of the session today. So next session we will be again meeting on Friday. Okay, so goodbye, enjoy your weekend, stay healthy, enjoy yourself. Bye bye then.
Thank you,
Thank
sir.
you. Bye.